Hello aspirant. This question is from GATE 2021 Mechanical Engineering Set 1 question number 35. Activities A, B, C and D form the critical path for a project with a Pert network. The means and variances of the activity duration for each activity are given below. All activity durations follow the Gaussian or normal distribution and are independent of each other. So activities A, B, C, D are given. Their mean duration is given in days and variance is given in days square. The probability that the project will be completed within 40 days is dash. Now as the activity durations follow Gaussian distribution, let's start with finding the Z score in order to find the corresponding probability. We have Z score in normal distribution. Z score Z is equal to the days for which probability is being asked to calculate minus TE. This is the total duration of activities on critical path, that is the complete project duration, divided by standard deviation sigma of critical path or of the complete project. Among this T is given, TE we can calculate by summing up all the mean durations and sigma we have to calculate. So let's start with calculating TE. So TE is equal to sum of all mean durations. Activity A has mean duration 6, B has 11, C has 8 and D has 50. So the sum is 40. Then we have standard deviation of critical path. To find the standard deviation of critical path, we will have to use under root of variance of critical path. And this variance of critical path is nothing but sum of variance of each activity, which is equal to under root of summation of variance of activities. This is nothing but square root of, we have 4 plus 9 plus 4 plus 9, whatever as the variance is given in day square. Hence we will get the standard deviation of critical path under root of day square. Standard deviation we will get in days, root over 26 days. Putting in the formula of Z, we will get 40, the duration for which probability is being asked to calculate. So 40 minus 40 divided by root 26, which is 0. Now Z score is 0, probability is not 0. We have to find the corresponding probability to Z equal to 0. So we have to find probability at Z equal to 0 is. To find out this probability, we will refer to the graph between Z and probability density function. So for the normal distribution with 0 mean, we have the curve for probability density function as a symmetric bell curve. It is symmetric about Z equal to 0. So finding out the probability for corresponding to Z equal to 0, we will find out the area to the left of this line. Now we know that complete area under the curve is 1 or 100% because maximum probability is 1. So the area under half of this curve, as the curve is symmetric, will be 50%. So we have probability corresponding to Z equal to 0 is equal to 50%. We are being asked how much is the probability that the project will get completed in 10 days. So if the project duration is 40 days, for this project to get completed in 10 days, definitely the probability is very low. Let's check whether it will be giving the correct answer. So Z score in this case will be 10 minus 40 by root 26 and this value will be negative. Whatever is the magnitude of the value will be negative. That means we are going to the negative axis or the negative Z side, and when we calculate a probability corresponding to this, it is giving us only a very small area. That means the probability will be definitely less than 50%. If let's say we calculate a probability for very high duration of 60 days, Z will come out to be positive in this case. 60 minus 40 by root 26, it will give us a positive value, that is to the right of Z equal to 0 or to the on the positive Z axis. So we will definitely have a probability greater than 50%. So our answer in this case is 50%, but the answer has to be written in pure number. So we will write it as 0.5. Let's just fill the blank with the answer. The probability that the project will be completed within 40 days is 0.5. Probability is unitless, of course, and it is 0.5 here. To understand PERT in detail, you can refer to the NPTEL video, Lecture 53, PERT and Crashing, Production and Operation Management by Professor Rajat Agrawal, IIT Roorkee. I hope this explanation will help you clear your doubt. Thank you.